Good afternoon, algebra class. Today we're going to be doing section 4.6, which is talking about formalizing relations and functions. And first thing we're going to start with is just relating some things that we've talked about. What a function rule is. A function rule is just an equation. And then we're going to talk about the x values here. X values are the input and the domain of a function. So those three things are all related. And then the last thing we're going to talk about is that the y values are the output, and we also call them the range. So those three things all are the same thing. So when we ask for you to use a domain, we're giving you x values. When we ask you to find a range, we're asking you to find y. So down here, we're identifying the domain and range of this relation down here. And we find that the x's, these are just ordered pairs down here. The x's are the first numbers. So in this case, this is an x, 5 is an x, 7 is an x, and 4.2 is an x. And then we go over to the second one. Second value is a y. So we get 4 y's that are associated with those x values. So over here, when we want to list those, we find that the domain is the first list here. We've just taken and listed the numbers. I want you to notice 4.2 is listed twice, so we just list that once over here. We don't have to list it twice. And then the range is the y values. That's our output. So we're going to do what's called a mapping diagram by drawing arrows that connect numbers to their relation. So 4.2 will go to 1.5, and it goes to 0. And then 5 goes to 2.2, and 7 to 4.8. And what we have to do is identify, does this relation map each domain value to exactly one range value? And the answer to that is no. If we see here, 4.2 actually goes to 2 y values. So this does not map each x value to one y value. It maps it to 2 in this case. So for our relation here, we're talking about this relation, it is not a function. In order for this to be a function, we cannot have any one x value go to 2 y values. So when we're listing our x values, if x is listed twice, it's automatically not going to be a function because it's going to 2 different y values. We can also determine if a relation is a function by doing what's called the vertical line test. The vertical line test will decide if a relation, which is just an x and a y, is a function if the vertical line does not cross the function more than once. So if it happens to cross it twice, then we're going to say that it's not a function. So to do this, we're going to need to graph these ordered pairs. So we're going to graph 4, 2 first, and we're going to graph 1, 2, 0, 1, negative 2, 2, and 3, 3. So we can see that if we were to draw vertical lines through this, we can see that our vertical lines only hit each point once. That one was not so vertical. There we go. So in this situation, we can see that our values here each have just one dot on each line. Now I want to show you the difference between this function and the previous one. You can notice that y is repeated, and that's okay to have y repeated. We can have different x's going to the same y. We just can't have two x's going to the same y. So in this situation, this is a function. The vertical line test confirms that. So this will do a, so this is a function. So I'll label this relation a function. So no on this, they intersect more than one point. It does not. So we can draw a vertical line that intersects more than one, and it can't. And so this is a function. Now we're going to talk about dealing with a function or an equation. So here's a function rule, and I'm giving you the domain. These values, remember, domain just means x values. So we have 4 x values here, so that means we're going to get 4 y values. So we're going to find g of 1, g of 3, g of 5, and g of 7. Now, if you remember from yesterday's lesson, this is just function notation. This is saying take 1 and put it in for x in our equation. So we're just going to put 1 in place of x. This is saying put 3 in place of x. That is saying, this one here is saying put 5 in place of x. And then the last one is putting 7 in place of x. Now I want you to notice I'm not going to do anything with this over here. This is just simply for notation. So I'm going to write that. This is just notation. You do nothing with it, no calculations. The calculations are over here. These are the calculations. This is just a notation. So we would do 4 times 1 and subtract that from, or subtract 12 from that, and we get -8. Then we do 4 times 3, which is 12, minus 12, which is 0. 4 times 5, which is 20, minus 12 will give us 8. And then our last one is 4 times 7, which is 28. And we subtract 12. I should erase my extra little line here. That's not equals. And this last one will be 16. So our range for this problem, to write it in a list form, is going to be -8. Our range is -8, 0, 8, and 16. So we found the range for this problem. Our last example is identifying a reasonable domain and range. So here we have a problem where we're given an equation. So our equation in this case is saying that the area formula is the area of the wall that we're going to paint is 100 times Q, where Q is just going to be the number of, or the amount of paint that we're going to use. So we're given a 7-quart paint, and then we're going to paint that each quart covers 100 square feet. So if we represent the area in square feet, that Q quarts of paint cover a reasonable domain for this problem. So in this situation here, we would say a reasonable domain for this problem, meaning, if I could spell domain for this problem, would be talking about our paint. We have 7 quarts, so that's going to be the most that we're going to be able to use. And then I'm going to write a little inequality here and let Q be in the middle. If you remember, this is just a compound inequality. And we're going to say that our amount of paint, we could use anywhere from 0 quarts of paint all the way up to 7 quarts of paint. So basically between 0 and 7 quarts of paint is what this inequality here states. The range would be the amount of paint that would be actually applied. We could use 0, and then our area could be anything between 0 and 700. Because if we use 7 quarts, 100 times 7 would give us 700 square feet that we would paint. So our domain would be using anything between 0 and 7, and our range would be anything between 0 and 700. So that's how you would identify a reasonable domain and range from a word problem. So we'll do some examples in class. When you're done with the video, make sure you answer the questions, and we'll see you in class tomorrow.